Okie dokie, friends. So we march into what Thomas, from beyond the grave, has called Chapter 10. Chapter 10 is a discussion on infinite series, and you can't discuss infinite series without discussing sequences. So this screencast discusses sequences. Pardon me while I shift to a calligraphy pen. So let's talk about what a sequence is. A sequence is an ordered list of numbers. It's an ordered list of numbers. Now, other people will define sequences as a function from the counting numbers into the set of real numbers, and that's fine. Sequences are usually set apart with those set brackets, and we refer to the nth term as a sub n. So, for example, a sequence might be 0, 1/2, 2/3, 3/4, and so on. And so when we say that a sequence is a function from the counting numbers to the real numbers, this is f of 1, f of 2, f of 3, f of 4, and so on. A1, A2, A3, A4, and so on. You might have a sequence B sub n, and the B sub n sequence might be 0, -1, 2, -3, 4, and so on. That would be fine. This is B sub 0, B sub 1, B sub 2, B sub 3, and so on. You might have a sequence 5, 7, 9, 11, and so on. This would be a familiar sequence to you from high school. It's an arithmetic sequence. You might have a sequence 4, 6, 9, 27 halves, 81 fourths, and so on. And that would be super fine. This is a special kind of sequence that you learned about in high school. This is called a geometric sequence. So one of the things that we like to do with sequences is we like to quantify somehow what the nth term in any sequence is if we can indeed find a pattern. So you might notice for an arithmetic sequence, it is totally possible for an arithmetic sequence to write down that the nth term is 5 plus, and then each time we go up by 2, so we go up by 2 each time. How many times do we go up? We go up n minus 1. And this is something you would have picked up in Algebra 1 or Algebra 2, depending on where you went to school. Likewise, you might write the nth term here as 4 times 3 halves to the n minus 1. Why 3 halves? Because we're multiplying by 3 halves every time to get from one term to the next. The others are a little bit more complicated. The others, what's a good A sub n there? What's a good B sub n here? Remember, this is A 0, this is A sub 1, I'm sorry, this is A sub 1, this is A sub 2, this is A sub 3, this is A sub 4, and so on. This is B sub 0, that's B sub, no, I did that twice. Oh my gosh. B sub 1, B sub 2, B sub 3, B sub 4, and so on. So what does the nth term look like? Well, in each case here, the denominator appears to be whatever n is, and the numerator appears to be 1 less than that. So that's probably the good way to go there. Over here, the difference here is that the big number that's there appears to be 1 less than whatever n is, and then you just have to account for the fact that it goes minus plus minus plus minus plus. This is called alternation, and the way we usually define alternate, the way we express alternation is we have -1 to some power, and that power is either n or n plus 1, and I think you'll agree with me that that power in this case should be n plus 1. If you don't believe me, try a couple. Okay, good. So one of the questions that we like to ask about sequences is, does it converge? And here's the way we know. the sequence A sub n converges to the number L if and only if the limit that's not true, the limit as n approaches infinity of A sub n is L for some finite L. That's what makes a sequence converge. So what the heck does that mean? Well, that means, how do I know if this sequence converges? If I take n to infinity, do these terms get closer and closer to a number? And it appears that these terms get closer and closer to 1. And sure enough, if we took a limit of this as n gets large, we would say that that limit is 1. And so we would say that, I'll say it over here. We would say that A sub n converges to 1. Now, this sequence doesn't converge because the terms oscillate and they get larger in absolute value. So this does not converge. Similarly, this sequence will not converge. It just goes up forever and ever and ever. And the same thing here. None of B sub n, C sub n, or D sub n converge. They diverge. Okay? Okay. So I could give you an epsilon delta definition here, but I'm not going to do that. I'm just going to say that a sequence converges if and only if the limit as n approaches infinity of the terms is L. So let's play everybody's favorite game, Does It Converge? So does it converge? Here's the sequence U sub n, and that's 16, 19, 176 over 9, and so on, so that the nth term is 20 minus 4 over n squared, and it just goes on. Here's a sequence V sub n, and that sequence is 4 over 21, 9 over 33, 14 over 45, and so on, so that the nth term is 5n minus 1 over 12n plus 9, and so on. And just because I like having 3 colors to choose from, W sub n is 12, 8, 16 thirds, and so on, so that the nth term is 12 times 2 thirds to the n minus 1, and it just goes on and on and on. Yeah, it goes on and on and on. Time for you to play for a little bit. Does it converge? Okay. Oh, hey, while we're playing, does it converge? Does it converge? How about this sequence? Does that converge? Well, what do I have to know? I have to know if this sequence, if the nth term approaches a number. Well, the nth term, limit n approaches infinity of natural log of n squared over n. Well, this goes to infinity and this goes to infinity. Oh my gosh, L'Hopital. L'Hopital says, I take the derivative of the numerator, the derivative of the denominator, and try again. Luckily, the derivative of the denominator is 1. The derivative of the numerator is 2 times the thing times the derivative of the thing. That's 1 over n. Well, this goes to infinity. This goes to infinity. Oh my, let's try L'Hopital again. So if I try L'Hopital again, let's see. Derivative of the top, derivative of the bottom. Derivative of the denominator is 1. The derivative of the numerator is 2 times 1 over n. And I know what happens to this. This goes to 0, which means that this goes to 0, which means that this goes to 0. And so we say that the sequence converges. Well, that's crazy, isn't it? Okay. Sometimes sequences are given recursively. Sometimes recursive sequences pop up. So let's play Does It Converge? the sequence where a sub 1 is 2 and a sub n plus 1 is a sub n plus n. Well, how do we figure that out? Well, let's get a sense of what that is. Let's just get a sense of what the sequence looks like. First term is 2, and then a sub 2 is a sub 1 plus 1. Reasonable. And a sub 3 is a sub 2 plus 2. Reasonable. And so you have this sequence right here. Does this sequence converge? I don't think this sequence converges. Sorry. But you take a moment and see if this sequence converges. The sequence where the first term is 144, and then the next term is the previous term times a half. You see if this series converges. I'm sorry, this sequence converges. You can think about that for as long as you want. And that concludes our screencast. Mind you, there are 2 screencasts for this particular lesson. The next screencast will cover the basics behind infinite series, a lot of stuff that you're familiar with from high school. Okay, thanks everybody.